Think about the mental life of early humans, long before the invention of spoken words. Without a vocabulary for trees, predators, or tomorrow, what did the inside of their heads actually sound like? We rely on language as our primary tool for navigating the world, but developing that tool came with a hidden biological cost. Gaining the ability to name and categorize our physical environment required us to narrow our perception of reality. Dr. Julia Mossbridge is a cognitive neuroscientist who has spent her career studying how the human brain interacts with time. Her research points to language as a highly restrictive technology. When we think in words, we force the chaotic reality of time into a strict, manageable sequence of past, present, and future. This aligns with the filter theory of consciousness. The premise is that the universe is a massive, non-linear informational landscape, and our brains actively block almost all of it out so we can function in daily life. To survive, our linguistic minds stay grounded by ignoring the vast majority of available data. But if language is the mechanism filtering out the rest of reality, what information remains accessible to those who bypass that filter entirely? In the human brain, speech processing is concentrated here, in the left frontal orbital area. Researchers noticed a neurological anomaly in stroke victims with damage to this language center. With their left hemisphere suppressed, the right hemisphere became highly active. To test the physical effects of this shift, scientists used a computer cursor controlled by a random number generator. They asked these stroke patients to influence the direction of the cursor using only their intent. At statistically significant rates, the cursor moved exactly where they wanted it to go. Dr. Mossbridge took this further, organizing double-blind trials to investigate if similar cognitive effects occur in individuals with non-speaking autism. During one trial, a nonverbal participant was asked to describe a hidden, randomly selected video being transmitted mentally by a researcher in a separate room. Using a letterboard, the participant typed, "It's art of a beautiful sky." The target was a colored time-lapse of the Northern Lights. These participants demonstrate that without the intense verbal processing that dominates most human brains, the mind is free to occupy a broader layer of reality. During these trials, researchers documented what they called a telepathy train. Multiple non-speaking participants, completely isolated from one another, began sharing the same topics and internal experiences without any physical interaction. One participant typed out a specific mental technique to help him tune in to the correct target video. He visualized slamming a beach ball on the ground to synchronize his timeline with the researchers. Moments later, a different participant in a separate building entered the room and typed that they should try the beach ball slam. These experiments were conducted under strict scientific protocols. The participants were separated by physical walls, had no prior knowledge of the test materials, and the facilitators asking the questions were blind to the targets. Because the data from these trials shows a consistent mathematical pattern, we have to look for a physical, biological mechanism that allows information to bypass normal sensory routes. To find that mechanism, we look at the foundational building blocks of human biology, specifically the behavior of subatomic particles like photons. This is the setup for the double-slit experiment. An emitter fires a single quantum particle toward a barrier that has two distinct openings, with the detector screen waiting behind it. Instead of traveling through one hole or the other, the single photon behaves non-locally. It passes through both slits simultaneously, creating a multi-banded wave interference pattern on the screen. One explanation for how a single particle can interfere with itself is retrocausality, the principle that the flow of time isn't strictly one way. Dr. Mossbridge's data suggests a photon can interfere with its own future iterations, reacting to light particles that have yet to leave the emitter. This concept applies directly to human biology. The brain is constructed from these exact quantum particles, and there is evidence that those biological components operate under the same nonlinear rules of time. Tapping into information from the future is a byproduct of how our brains are built. Our active language centers are simply the filter that manages that noise. This framework defines telepathy and precognition as standard biological processes of the human animal. Acknowledging this biology changes how we view nonverbal individuals. Rather than being isolated, the science suggests they are attuned to a frequency the rest of us have tuned out. Governments and tech companies are currently pouring billions of dollars into building artificial quantum computers, yet we are walking around with organic quantum systems already operating inside our skulls. Accessing the universe's broader data landscape doesn't require new hardware or louder communication. Since language is the filter that grounds us in linear time, perceiving this informational landscape depends on our ability to bypass our own internal dialogue.